Think about the clean air, the economic gains, the energy security, taking price volatility out of your economic calculus so it doesn't keep whipsawing the economy. Exerting the world leadership that Indonesia is so deserving of, such a great country. Think about building your economy for success in the next century. That, not just climate protection, is where I think your conference can take your country. So I want to thank each of you in attendance for your leadership. You have great responsibilities and immense opportunities. Make the most of them. Terima kasih.
Thank you very much. And now we move on to, after we set the scene, it's great for us to start the day with some success stories. So to share with us some success stories, I'd like to invite the three panelists. Adi Sulisakyo, professor at the University of Indonesia, who will share a story on bio-waste. If you can join me on stage, and then we'll start the panel. Pak Agus Widianto, Executive Director of Yayasan Bina Usaha Lingkungan, and Shelley Chung, all the way from Hivos, Sumba Island Place, the Green Advisor of Hivos Regional Office of Southeast Asia. And first of all, we have, as I mentioned, Adi Sulisakyo, who will be sharing his story on a successful story on bio-waste. Adi, we've limited each of the panelists to 5 minutes. That's a challenge. But we want to give ample time for discussions afterwards. So the floor will be open for questions and answers. Silakan, Pak Adi.
Thank you very much. The moderator has please allow me to presentation my works from the laboratory to the local society. So, and this is my title is the experience implementation of bio-waste utilization. Okay, next slide, please. Yeah, I'm from the Universitas Indonesia and also for Tropical Renewable Energy Center in Faculty of Engineering. We are trying to develop some different renewable energy in Universitas Indonesia. Please, next slide, please. Okay, this is the content of presentation. This is the most of us about the gasification and the gas-bed combustion and the characterization of the technology application, traction for local society. It means that we try to communicate with the local industry. Okay, next presentation. Okay, since this is only 5 minutes, I must run through the slides. The introduction is energy supply of distribution in Indonesia, the problems of the energy for drying and electrical generation at different places in Indonesia, and it is important from research to application technology. Next, please. We have seen that Indonesia is the very big country in South Asia, but actually, we have distribution of the energy. This is the picture in Raja Ampat, and it's a beautiful place. Okay, please, next. We have said, as we know that from the previous presentation, we have a target of primary energy mix as set to 23% and renewable energy in 2025. And with economic growth more than 5% energy and demands increased to 7% to 8% annually. So the renewable energy has a high potential in bioenergy with the estimation potential around 49 gigawatt per year. Next please. The objective of the work is how to implement the renewable energy, especially in biowaste, in the electricity and the drying, and in a small scale. Okay, next please. And how to communicate with the local. And this is some of milestones of the implementation from the research lab, how the bio-waste utilization I divided into biomass gasification and fluidized bed combustion. And this is the output. This is the syngas and the heat energy. Next please. And this is some of the works, currently works in the small scale industry. Next please. And how we get the work is through the experience, simulation and work in the workshop. Next please. And this is fluidized bed conversion. We have made, we manufacture ourselves and we design for the purpose for coconut cell combustion, and it is success in the experiment and the implementation. But still we are working in our university. Okay, this is some part of the fluidized bed conversion. Next please. Okay, the characterization of the technology application. How we should attract the research to the local society, and we try to implement it in the small scale of clay ceramic industry. And this is the using the biomass resources. What we are now using this is mostly is the rice husk and some of the coconut shell and so on. What we are a lot of biogas around us. Okay, next please. You see that it's biogas in Indonesia. We have from the data. Actually, we have potential of 13,662 megawatt electric. This is very good. We can how we utilize for our building. Okay, next please. This is from academic research. This is some of the part in the lab. Okay. Next. Okay, this is fluidized bed combustion research. We try to how to make a drying, and this is the local society. I've mentioned how to involve in the production of clay ceramic industry and in small scale in this. In the West Java, not East Java, actually, Jakarta. We have already working together with the Minister SDSN Mineral. Okay. Okay, next please. This is the industrial project in the other places. Sarandi Karanugraha, we are trying to improve the gasification to create the flame and how to drying up the some kinds of the ceramic industry, small scale, and also the how to inject the gas. Next project is the to generate the electric. We have developed the connection within the synthetic gas to the small scale engine, and we have success working together with the local industry, and there is the owner of the big entrepreneur, and as the member of the Kadin. Kadin is the entrepreneurship of the chamber in Indonesia. There's some groups that's already supported the works, then try to initialize to implement in some places in the small scale industry. Okay, I think this is of my presentation. Next please. This is this is an reflection of local society in Barat. This is Jakarta. As a study until now we have done, we are doing now still working with the people over there. Okay, next. And but what is the topic here of engagement community in how this is this schematic of we are doing now. From the strategic development, problem formulation, and development method, we are trying to return from going to the local in the place and return to the universitas, to the lab, So we can, the output is the prototype of ceramic industry for capacity building to implement the gasification system from the rice husk. Okay, the next. This is the type of the from the small scale gasification laboratory to the local industry. We are trying to try the flame and to improve every time to make the certain quality of the ceramic or the clay ceramics at the low level of the product, local product. Okay, the next, please. Yes, this is me and the other person and assistants who works on this project. So I'm closing the presentation with the small statement. When individuals and communities do not govern themselves, they risk being ruled by external forces that careless about the well-being of the village. Okay, that is the end of my presentation. Thank you very much for the time I listened to you. Thank you.
Thank you very much, Pak Adi. And now I'd like to invite Pak Agus Widianto, who will be sharing successful stories in applied microhydro in Indonesia. Pak Agus Widianto is the director of Yayasan Bina Usaha Lingkungan, which is an NGO working in environment-based social entrepreneurship. Silakan Pak Agus.
Thank you for having me here. Microhydro is actually, I'm working in an NGO, and microhydro is one of our programs that we use for developing sort of social entrepreneurship mission in our NGO. Hope this presentation will give you some shared ideas on our experiences in developing microhydro. I call this presentation a microhydro development, a reflection of field experiences. This is the pictures of one of the microhydros that we developed. This is located in West Java. Next. This is just to give you a bigger picture that national consumption of electricity, according to the Ministry of Energy and Mineral Resources in 2013. There is an increase of 8% per year, with consumption consisting of household is still the highest demand. And now the national electrification rate is 81%, so there is still room for developing some renewable energy resources for electricity. Microhydro is one of alternative electrification sources. There is a thesis that I put in here. In the autonomy era, the energy needs could exponentially increase in its capacity, quality, as well as distribution demands. If the energy supply and distribution capacity do not respond to such demand, many Indonesian regional development will become stagnant. There are strong links between energy availability and development progress, especially in the regional development. One of possible solutions would be developing the hydro energy, and especially in rural areas, the microhydro generation. Why microhydro? It's environmentally friendly, of course. It's renewable energy sources, and most of all, Indonesia is endowed with enormous hydro energy resources. Manufacturers are ready. Now they start to decentralize the capacity. It used to be one in Bandung only, that big manufacturers there, but now spread throughout the country. Relatively low operation cost, long-lasting and suitable for villages in Indonesia, which normally are endowed with potential river systems, can be built as a standalone system. Doesn't depend to other sources. The microhydro potentials, this number is developed by IMIGAP, a program from the ESDM. There is 3.5 million kilowatt. But you know, the interesting thing is that the existing micro hydro developed is only 13.1%. So it's very, very low. Normally in the villages, the most commonly developed is people ecosystems due to the suitable basic requirements, which is height, the difference between the height of water and also the water volume. And there are some definitions that people hydro is 5 to 50 kilowatt. There are some differences of this definition, but this is kind of common. Micro hydro is 50 to 100 kilowatt, and mini hydro is 100 kilowatt to 1 megawatt, and others. Some field experiences, micro hydro depends on at least 4 elements or modalities, so to say. One is environment, which is consisting of river systems as the main source for turbine rotational force, water volume and head. Social element, communal setting for operation and maintenance of the system, needs specially established management units, because micro hydro cannot be developed as individual project. It has to be a communal due to high capital cost. Technical element or civil construction, ranging from dam intake, settling basin, headways, up to the terrace, mechanical as well as electrical systems. Financial, this element needs to be explored further, because normally now it needs a significant amount of funding. It's about $300 US to 3,000 to 4,000 US dollars per kilowatt. So if you want to develop some micro hydro for example 20 kilowatt, then you have to just times those costs. And possibly reach to 5,000 US dollars. It depends on the transportation cost. Micro hydro is normally developed in very remote areas, so transportation could be very high in transporting all the mechanical and machinery. As well as site condition, which varies. Site condition meaning that in some areas the penstock needs to be longer, the bay, the settlement area should be bigger, and so on. Financial element also deals with cost for operation and maintenance. Agreed upon tariff for subscribers as well as rate of installments should the project cost was obtained from loan. Common difficulties: access to financial capital for micro hydro systems development, which point ranges from $50,000 to $75,000 per site, depending on the big of the amount of the kilowatt. Organizing community for operating and maintaining microsystem is also one of the difficulties. Difficult to obtain consensus and commitment. This is what we have been doing. Getting consensus among community, and then also obtaining a commitment for them to really operate and maintain the system. For example, like establishing village management units, it's kind of, we call it kelompok pengelola or management, community management units. Developing sound financial management systems in collecting the fee from each community. Maintaining water catchment areas for sustainable water supply. This is also one of integrated work that need to be done. But most difficult thing is that when PLN or the state electrical company comes in, then the system can collapse, because they will choose the PLN instead of micro hydro. It will be easier for them to just on and off the switch and not maintaining the system. This is the increasing sustainability. Okay. 1 minute. Ensure the local communities are well aware of the overall elements. Promote the use of electricity for productive use, so that they can generate funds for maintenance and operation. Develop self-financing mechanisms for maintenance and operation. Select areas where PLN has no near future plan to provide electricity. Explore implementation of payment for environmental services, or PES, where integrated approach can be developed to maintain the water catchment area. Then what? I think what we think is that financial barriers for micro-hydro development needs to be resolved. For example, like developing public-private partnership funding schemes to provide partial subsidy to a community. PES need to be developed. Decentralized capacity for turbine and spare parts manufacturing to establish less dependency on the existing is it's happening. The decentralization of the manufacturing is happening during this. I think that's all that I have to say. Thank you.
Thank you very much, Agus. And last but not least, we have Shelly John Caldwell, who is the Regional Green Advisor of HIVO's Regional Office in Southeast Asia, who will be sharing the story of the HIVO's Sumba Island.
Good morning. What a pleasure to be here today with all of you to share our story about HIVO's Sumba iconic island. Next slide, please. Next slide. Okay. The core idea of the Sumba iconic island is HIVO's beliefs. There are two of them. The first is that access to clean, affordable energy is a fundamental right for the world's poorest people as well. And the second is that 100% renewable energy is possible. It can also be realistic if we choose to set our minds to it, both locally, nationally, and globally. We decided to apply these beliefs to test our vision of 100% renewable to Sumba Island, which is one of the most disadvantaged regions in Indonesia. Our vision is actually closely aligned to the stakeholders of energy planning and development in Sumba. For instance, I'll give you an example. Electricity in Sumba was provided by PLN's diesel power generators, diesel being very expensive to ship to Sumba, and electricity grids being exceptionally expensive to extend to the very scattered population of Sumba. So the stakeholders, when we arrived in Sumba, already realized that they have an interest in renewable energy, and they're being pressured by the central government to increase the electricity ratios and to fulfill the promise of the mix of 25% renewable energy, which we promised by the Indonesian government. So we arrived in Sumba, and the stakeholders are interested in renewable energy, but didn't quite know how to achieve that. And we worked with them. Over the past 4 years, we have facilitated cooperation and removed barriers to the installation of renewable energy. Our role is to demonstrate new technologies on the ground with sustainable business models, and to provide technical assistance and education to policymakers, planners, and communities to show that this vision is possible. In doing so, this vision is no longer HIVO's vision, but in fact, it's a joint vision by all the stakeholders. Next slide, please. So you see there's a large number of stakeholders. The process is currently led by the Ministry of Energy, SDSN, and we anticipate by 2016, financially, the process will be taken forward by the Ministry of Energy for coordination. HIVO's will remain to support, and we see that it is a long-term effort. This is completely the opposite of many traditional development interventions, where you go in, you build to a predetermined set of targets, and you get out. But here we are committed to all working together to this vision over the long term till 2025, 100% renewable energy in Sumba. Next slide. Next slide. I'll just skip. One of the great things about the iconic island concept is that it's inherently replicable. Anywhere where conditions are favorable for renewable energy and the stakeholders are willing to work together, we can implement this process. We could even do it in the forests of central Kalimantan. It doesn't have to be an island. Next slide. The most important part of this process has been the commitment of the stakeholders. And that has been demonstrated by a financial commitment from the government to support the coordination process, and also for district governments to commit to implementation of renewable energy on the ground. And we have achieved good progress on both these fronts. Private sector investment will have to continue to be supported very strongly by government. We cannot expect the private sector to lead the way in Sumba, given its disadvantaged status at the moment. Next slide. I'll briefly take you through some of our interventions. With on-grid activities led by the stakeholders, we have increased the electrification ratio quite substantially, even only over these last 4 years. Next slide. This is one area that HEVOS leads the way. We implement microhydro and mini grids. And the idea is that we develop these installations, and eventually they're taken over by PLN for maintenance, with profits going back into the communities who manage them. But a really important thing is that we demonstrate to PLN and other stakeholders that these solutions actually work. We need to ask them to inherit sustainable business models and equipment that will continue to function. Next slide. One of the core aspects of HEVOS's work has been to develop sustainable business models. We have found that people are willing to pay for renewable energy if the equipment performs as promised, and there are mechanisms for loan repayments and extension services and for repair. So what we've found is we need to develop renewable energy ecosystems. We develop the whole sector, from suppliers to extension services to loan providers. We currently provide subsidized services in Sumba. We subsidize at approximately 20% with the subsidy provided by HEVOS or by the government. But elsewhere in Indonesia, we've found that farmers and users are willing to pay 50% to 100% of the costs, especially in Java. Next slide. One thing we do is we always link new technologies to what you can do with them. We don't just give people lighting, but we train people in the development of micro businesses, new activities. Sumba being Sumba, a lot of the focus is on agricultural, harvest processing, storage, things like that. But this has the virtuous cycle effect of stimulating user demand for energy once they see how it can be used. Next slide. The key success factor for our project, I think, is finding commonality amongst the stakeholders, even if the reasons behind their cooperation is different. HEVOS is obviously coming in as an international development organization, looking out for the small people, the farmers, and on principle. But we find we can work with the private sector, with government, with people who are driven by financial and policy-driven concerns. That doesn't matter as long as our outcome matters, which is renewable energy for all, pretty much. Thank you. That's short and sweet. Hopefully you have some questions.
Thank you very much, Shirley. Now, I realize that we've run out of time, but I'm going to allow for perhaps one question from the floor, if there are any. I think you'll all be available here as well throughout the day, so if you have any questions to them, you can pose them as well. And I think the presentations are also going to be made available by the committee. So if you don't have any burning questions now. Okay, yes, please.
My question to have you considered
Thank you for that question. That is something we have not considered yet, but in fact recently came across our radar with discussions with some private sector parties. We have been told that ocean energy could potentially be used on the shoreline for supporting cold storage facilities for the fishing industries. So yes, not yet. We haven't trialed any pilots, and it's not on the roadmap, but perhaps in the future it definitely will be. So thank you for bringing that up.
Okay, maybe one last question. I can't resist. Can someone give me a mic? Or Bobby, you can just step up here.
No, it's okay. I think I have a lot of speak up. Okay, saya pilih bertanya satu ke Pak. Yang pertama Pak, yang di flare tadi. Itu berarti dia yang disuplai di flare itu adalah thermal, bukan elektrik. Artinya apakah efisiensi pemakaian thermalnya itu sudah mencukupi yang selama ini ada di sana? Itu pertanyaan saya pertama. Terus yang kedua begini untuk kampus, I think it's a very interesting one. We have a target and a vision of 100% renewable energy. I think it's very challenging, and I like the idea. And thanks God, the population is still 660,000 people. But what happens if it's increasing? Are you still going to maintain the 100% renewable energy solution? This is what my question is. And how are you going to achieve it? Are you going to use multi-system like solar, like micro hydro, and wave, wind, all that stuff? Because last time we had made surveys of the wind turbine solutions in all over Indonesia. It looks like the wind speed or the speed of wind is not good enough to generate electricity with the turbine which is existing today. I don't know. I think only have the technology to be able to absorb the low speed wind to generate electricity.
Thank you very much, Uncle. Andy, would you like to? There's a microphone there, I think. Yep, it's on.
Since question is in Bahasa Indonesia, allow me to speak in English or English?
If you can speak in English, that'd
Yes,
be great.
okay, thank you very much. Yes, the thermal efficiency, we have calculated and measured in the, we have built some combustion equipment measurement that is this kind of the thermal is we have a certain thermal efficiency range based on the type of the biomass, such as we have the lower thermal efficiency since the carbon content of the rice husk is very low. So we have around 30% of thermal efficiency, and the highest is we are using the coconut shell is a little bit higher. It's around 55 to 60, depends on the moisture content. And since we have the problem is the moisture content, for example, nowadays is rainy season, so we must pre-treatment. So we try to build and design the drying system, but the system drying, we are using the heat from the system itself. So we are trying to gain the drying system and the thermal system. Now it is tried in, we are still calculating, and we have tried to already develop in simple one. But it is working very well in a small scale. We are trying to more manufacture it in little big scale. And that is my thank you very much.
Thank you very much. Would you like to?
Thank you for your question, Pat. Firstly, the target of 100% renewable energy has been deliberately chosen to be a little audacious, a little provocative perhaps. This is our flagship project, and we want to stimulate people's imagination as to what is possible. So, realistically speaking, we're aiming for about 80% by 2025. But on your second point, thank you for bringing that up. There is an issue in the tropics of slower wind speed, and in many countries where wind technology has been advanced. For instance, Danida, the Danish international aid organization, is supporting our wind turbine project along with a private sector partner. We will trial that technology first, which is designed for higher wind speeds, but we've been assured it will work. But we've also been apprised of the fact that in Indonesia it is possible to purchase wind turbine technology that is suitable for the slower tropical wind speeds. So we'll be exploring that for the future, and wind will definitely be a large part of our work in Sumba, depending on the pilot program with that 500 kilowatt turbine in Manoprani. Thank you.
Okay, the committee's going to kill me, but one last question.
Thank you. Ari Lehman from the Australia-Indonesia Centre Energy Cluster. You may tell us very briefly.
Yes, Ari Lehman from the Australia-Indonesia Centre Energy Cluster. Thank you for inspiring talks. And very short question for Shelley. What is what makes your project replicable, and what can be done to replicate these other things faster?
What makes it replicable is the fact that it does not depend on a fixed plan for rolling out any particular technologies. It is more a concept of cooperation, of identifying barriers and bringing them down, and pushing stakeholders to recognize their commonalities. It is for HEFOS, the implementing agency, to demonstrate technologies that are applicable to that particular area that you work on. If we move from Sumba and replicate in the forests of Kalimantan, for instance, we imagine it will look quite different. People there will have different needs, and wind and ocean will not play as large a part. So we will trial their technologies that are suited to the area. So it's a very general concept. That's what makes it replicable. We try and be flexible, and a large part of our imagining of this concept is that we be guided by below, and the plan is constantly changing. And this makes a lot of donors quite anxious, because we don't promise fixed targets, especially in megawatts. We will deliver X megawatts. Well, I hope that partially answers your question.
Thank you very much. A round of applause for the panelists. And that basically closes the session. The challenges are many, but we've heard now 3 different solutions, possible solutions, and there are solutions, and that's why we're here today. I wish everyone a great day listening to all the possible solutions and what lies ahead for the future, especially for Indonesia, the region, and of course the world. Thank you very much. I'd now like to invite Ibu Mari, Professor Kue, Pak Yan, and Dr. Putra to join us on stage to receive a token of appreciation from the committee. And I'd like to invite Pak Idis and Sherry. Oh, Shelly, please, yes, no, stay on stage as well, to join us. Is Sherry around? Okay. The token is coming, is walking. The peacock is making its way in. I always stare at it in awe every time I see it. Sherry, if you could please join us in presenting this to Ibu Mari and Pak Putra and of course